Your ASP.NET Core APIs are leaking performance, and standard JSON usage is the culprit. Human readability is comfortable when you are debugging, but high-frequency machines do not need to read text. They require data processed at wire speed. Over the next few minutes, we are going to strip away those bloated text payloads and replace them with Protobuf's compact binary encoding. To follow along, you will need three things: an existing project in ASP.NET Core, which is Microsoft's cross-platform framework for building web applications, an IDE, which is the software application you use to write your code, and an API testing tool. Executing these steps will result in a physically measurable drop in both your API latency and your total payload size. JSON relies heavily on redundant, repetitive labels for every single piece of data it transmits. These text-based labels act as useless weight during data transmission. Every bracket, comma, and key consumes bytes. Protobuf strips out those labels entirely. It transmits raw data in a compact format, relying on a shared schematic to know what each byte means. Eliminating this parsing overhead increases the speed of high-frequency services. When an API handles thousands of concurrent calls, saving milliseconds on every single request prevents total server bottlenecks. Adopting a binary format is about removing the processing latency that occurs during traditional text serialization. We start in the development environment by establishing a contract-first architecture. This means we define our data structures strictly in a schema file before writing any application code. Create a new file named message.proto. Inside, define a simple message structure, like a basic user profile, assigning a specific numbered tag to each field, such as an ID and a name. The primary failure point here is forgetting to instruct the IDE to compile this new schema file. If you skip this, the system will not generate the code you need. To fix this, right-click the .proto file, open the Properties menu, and change the Build Action dropdown directly to Protobuf Compiler. Completing this configuration ensures a consistent contract. It allows the system to read your schema and automatically generate C# classes that match your data structure exactly. Now, install the Protobuf NuGet packages. NuGet downloads and installs external libraries. Once installed, navigate to program.cs. Next, append the Protobuf formatters to your service container builder. You do this by attaching the Protobuf formatting extension directly to the Add Controllers chain. With the formatters active, create a simple GET endpoint. A GET endpoint is a specific web address that clients use to retrieve data from your server. Set this endpoint to return the C# object that was automatically generated by your proto schema. To verify success, trigger a project build. If the build finishes with 0 errors, your auto-generation and configurations worked correctly. By wiring these services together, you have configured the application pipeline to bypass standard JSON parsing in favor of high-speed binary streams. We are ready for the API testing phase. Keep in mind that default browser requests will still automatically ask the server for standard text formatting. You must manually change the accept header to demand a Protobuf response. The accept header is a piece of metadata sent by the client to tell the server what specific data format it expects in return. Set this value explicitly to application/x_protobuf. First, take a baseline measurement by sending a standard JSON request. Note the response time and the total size of the payload. This side-by-side bar chart shows the results. The tall red bar represents the heavy size and latency of the JSON request. Right next to it, the dramatically smaller green bar represents the exact same data requested via Protobuf. These metric reductions remove a significant serialization bottleneck, allowing your application to process more requests per second with fewer resources. You have successfully implemented a high-performance binary serialization endpoint. You have removed the overhead of JSON parsing from this pipeline, allowing your data to move as fast as the network allows. Take a look at your existing microservices. Microservices are small, independent applications that work together to form a larger system. Identify your heaviest, slowest endpoints and apply this exact contract-first template to them. Moving beyond JSON provides a significant path toward improving system efficiency and ensuring your architecture is optimized for high-traffic environments.